I'm Lorenzo Cappiello, and I am a second year PhD student at King's College London's IUPPN, and today I will present a research plan for a study on mentalization. Mentalization, or understanding others' minds, is central to social interaction, but how it works in everyday life remains unclear. This research explores how individual differences in beliefs and worldviews shape mentalization. We propose a computational model based on two main theories. Following mind space, we believe people represent others in a multidimensional trait space with traits like personality or intelligence that are relevant to the action context. This is then implemented and informed by intuitive theory of psychology. Once a mind is located in mind space, internal causal models aid the interpretation or prediction of such action. Unlike other models that directly map traits or actions to other actions or future actions, we model mental states as intermediaries to enhance prediction accuracy and explanatory power. Our approach uses directed acyclic graphs, DAGs for short, informed by elicited probability distributions to simulate participants' beliefs and mental inferences. We hypothesize that our latent factor model will better replicate participants' judgments compared to simpler recognition models. Test is, we use Minecraft as a study environment. Its open-ended nature allows for behavior resembling real-life interactions while minimizing the variability of possible action, intention, person-type combinations, and other sociocultural influences of the real world. We conducted interviews to understand how players perceive others in the game, which informed then the creation of the stimuli. Video clips of players performing actions paired with intentions and player types. These 20 players reported their personality in and outside the game. They were then recorded during a game-free session where they were instructed to play in a way that represented them, while 4 macro activities were given, for example killing a mob, to ensure that everyone took part of the same activities. How, when, and why the activity was approached was at the discretion of the player themselves. Intention behind some of the action patterns were also recorded, and the snippet's creation was preceded by qualitative analysis to reduce possible selection bias. Participants will report the causal model, estimate probabilities for actions, intentions, and player types using toggleable histograms, and then complete tasks predicting intention or types of players based on observed action or description of the player types. These responses will then inform the parameters of our computational model. The computational model is based off Julian and colleagues' work. You could imagine participant intuitive models to be constructed in one of two ways. One could be read as follows: because people have certain player types that have different intentions, which then leads to different actions. The other alternative is that because people have different intentions, there are different player types, and because of this reason, they will do a certain action over another. The key difference lies in their inverse inference process. The first model sums over all intentions to infer the player types from the action, whereas the second sums over all player types to infer the most likely intention. Both these models will be compared with each other and with a model that does not take into account the latent variable of interest, called the recognition model. The model will be evaluated on its ability to replicate participants' judgments, with accuracy assessed using metrics like root mean square error, mean absolute percentage error, relative standard deviation, correlation, and hotelling t-squared. Model fit will be tested using base factor, BIC, AIC, and leave one out cross-validation. We expect the reasoning model relevant to the participant to outperform alternatives showing high concordance with elicited beliefs and low prediction error. If successful, this study will illuminate how intuitive psychology drives mentalization, identifying where individual beliefs and stereotypes impact inferences. This framework could offer new insights into how we understand others in complex dynamic environments such as groups. Thank you for listening, and I welcome your feedback. Please use the QR code I provided.